In this video, you will learn about coordinate geometry. And more specifically, we will learn how to find the distance between 2 points, and we will learn how to find the midpoint of 2 points. So here we have 2 points given to us, and our objective is to find the distance. So the points are at 4, -2, and at 1, 2. So we want to find the distance between these 2 points. And to do that, it's helpful if you can visualize drawing a triangle in here. So we have one line connecting the 2 points, and then we have a vertical line going down to our y value, and then this horizontal line going over to this point. So we have a triangle that looks like this. Okay, this would be a right triangle because this is a 90-degree angle right here. Okay, so with a right triangle, we know that we can find a missing side length by using the Pythagorean theorem, which says that c squared is equal to a squared plus b squared. So to calculate the distance between these 2 points, I can simply find the hypotenuse using this Pythagorean theorem. And by the way, these numbers 3 and 4, they came from the fact that I can count over 3 places and then up and down 4 places. So I just count the number of spaces down I go and the number of spaces to the right I go to get 4 and 3. So what I do is I can just plug in those numbers into the Pythagorean theorem, and we get 4 squared plus 3 squared. So 4 squared plus 3 squared equals c squared. So then c squared would be 16 plus 9. So c squared is 25. So c is the square root of 25, which is going to be 5. Okay, so we can do this with Pythagorean theorem. But the thing is, we don't want to have to count to get the numbers 3 and 4 every time. Because if our points are fractions, or maybe it's just big numbers and it's too difficult to count, we don't want to have to do that every time. So the question is there an easier way to get those numbers 4 and 3 instead of counting? The process will be the same with the solving, but the question is, can we put something in here in between these 2 steps to get 4 and 3? So the way to do that is we look at the points that we had to begin with. So we had 4, -2, and 1, 2. Well, notice if I look at the 4 and the 1. So look at the x values, 4 and 1. If I subtract 4 minus 1, notice I get 3, which is the 1 side length. Okay? And notice if I take, let's say, -2 minus 2. -2 minus 2 is -4, but if I make that a positive, so just change the sign to get a +4, that gives me the other side length right here. So what I'm doing to find the a and b value, I'm subtracting my x values. So I take the 2 x values and subtract them. That gave me the 4 minus 1, right? And then for the second point, or the second side, I subtracted my y values. So the second y value minus the first y value. So that's all I did. I subtracted the x values and subtracted the y values. So instead of a and b, we can plug in instead an x2 minus x1 and a y2 minus y1. So this is my a value. That is that side length of 3. And here, y2 minus y1, that is b. So we have a and b. So if I do that, I get the numbers 3 and 4, which I can then use to solve. So my formula is simply using the Pythagorean theorem. Alright, and if I wanted to solve this for distance, alright, so instead of c for hypotenuse, we use d for distance. It's really the same thing. The distance between the 2 points is the hypotenuse. To solve for d, I have to take the square root of both sides. Right, to get rid of the square, I square root. So when I do that to both sides. So I can say the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So this here is my formula. Now, I personally do not like formulas because they're difficult to remember. So when I think through this, I just think Pythagorean theorem. I think right here, and I just ask myself, how do I get a and b? Well, I subtract the x values and subtract the y values. So whichever is easiest for you, personally I prefer to think of it like this up here, but you might prefer this technical formula where I have it solved for the distance. Let's take a look at another example. Here we have two different points, and we're trying to find the distance between the points -4, 2 and 2, -1. Now the formula comes from the Pythagorean theorem. Alright, so you can just use the formula, or you can just think Pythagorean theorem and plug in different things into that. If we use the formula, we would have d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I could just think through this, with the drawing and count and get 3 and 6 for my different values, but we don't want to have to count, we want to have to use the points. So to find those numbers, we take x2 minus x1. So if we let this be point 2, then this would be x2 and y2. If we let this be point 1, then this would be x1 and y1. It doesn't matter which one we consider point 1 or point 2, because when we subtract, we're going to then square that number, which doesn't make any difference. It's going to give us a positive number, as long as the x's correspond and the y's correspond. So from here, if we do it this way, we have -4 minus 2. That's x2 minus x1. So -4 minus 2 would be this first part. And then looking at the y2 minus y1, we take 2 minus -1. So just be careful with the negatives. -4 minus 2 is -6. 2 minus -1 is 3. So -6 squared plus 3 squared. That would give me a positive 36 plus 9. That is inside of the square root. So we have the square root of 45, which you can type into your calculator, and you would get approximately 6.71. So the distance between these 2 points is 6.71. Now, if you prefer to just think of this as Pythagorean theorem, we could do simply c squared equals a squared plus b squared, and just figure out what we have for a and b. Well, a is subtracting the x values, so -4 minus 2. And then b is subtracting the y values, so 2 minus -1. Alright, so that would be my a and b values. So if you do it this way, you get -6 squared. Here we have 2 minus -1 is 3, then squared. And those added together give me c squared. So c squared is 36 plus 9, so c squared is 45. Then solve for c by taking the square root of both sides. So c is the square root of 45, which would be that 6.71. So whichever way you want to think through the solving of this problem, we both get the same answer of 6.71. Now lastly, we're going to work with what is called the midpoint. So the midpoint is simply the point in the middle, or in between two other points. So to find that point in the middle, we simply average the x's and we average the y's. So that's what we see here. If we have 2 points and we're trying to find the point in the middle, we average the x values, so we add and divide by 2, and then we average the y values by adding and dividing by 2, and that would give me my midpoint. So again, we're averaging the x's and then averaging the y's. So for example, here we are defining the midpoint of the segment with endpoints at 2, 5 and -1, 9. Alright, so we can kind of see here in the picture, we have our 2 points, and we're trying to find the point in the middle. So if you imagine drawing a line segment connecting these 2 points, and that was kind of a junk drawing, but you get the idea. We're trying to find the point right in the middle. Alright, So to do that, like I said, we average the x's and then average the y's. So 2 and negative 1 are your x's. So to average, we add and divide by 2. 2 plus negative 1 is 1. Divided by 2 is 1 over 2. So my x value is 1 over 2. And then my y value we find by averaging the y's. So 5 plus 9 divided by 2. That gives me 14 over 2, which is 7. So my midpoint, the point in the middle, is going to be right here at 1/2 7, or 0.57. So let me erase all that ink right there. It's easier to see now. The point in the middle is right here at 0.57. And that looks right? If you draw a line segment connecting these, the point right in the middle would be right here at 0.57.